Hi everyone, this is Madhavi, working as assistant professor in Laxman Institute of Technology and Management. Today I am going to discuss about computing paradigms in cloud computing. First of all, course outcomes. These are the first unit of the course outcomes in this cloud computing. Next, lecture agenda. Today, these topics are covered in this session. First one is high performance cloud computing, parallel computing, and distributed computing, cluster computing, grid computing, biocomputing, mobile computing, quantum computing, optical computing, nano computing. These topics are covered in this session. First of all, computing paradigms. What is paradigms? Paradigm means fundamentals of approaches to computations. These are the performance and scalability, efficiency and innovations are these are the computer paradigms. Defines how problems are solved using computing systems. Focuses on evolved to meet growing computational demands. Nowadays, these clouds are mainly used for the cloud resources. These are the main reason of the cloud paradigms. Okay, coming to high performance computing, HPC. Okay, uses supercomputers are powerful processors solved complex scientific and engineering problems, perform trillions of calculations per a second. These are category into three types: weather forecasting, climate modeling, space researches. Example, create, submit. Okay, these are the high performance of the cloud computing. Coming to parallel computing. Parallel computing means multiple processor worked simultaneously on a one task, performed by the divided into smaller subtasks. These are the divided into two types. First one, data parallelism, task parallelism. For example, our college, number of systems are there in this college. Like labs, these are connected to the one server the data, and these are connected to the databases of the number of systems. This is called parallel computing system. Okay, coming to the need for cloud computing. Traditional systems have high cost and limited scalability. Cloud computing provides a on-demand resources and pay-as-you-use model, global accessibility, enable fast deployment and flexibility. These are the need for the cloud computing. Coming to cluster computing. Cluster computing is a group of connected computers working as a one system. Each computer is called a node. Okay, node share workload. These are the high availability, fault tolerance. Some particular data, for example, some particular input data. These are main system, like parent class divided into child classes. Okay, some particular amount of data connected to the main parent child. These are the divided into number of child data, divided into some results are there in this cluster computing. Okay, next, grid computing. Combines resources from multiple locations, heterogeneous system connected via networks, resources shared across organizations used for the grid computing. Large scale scientific projects, data incentive task. Like grid computing means, for example, multiple locations means first location is HYD, next Delhi, next Goa. These are three different locations are there through connected to the internet. Okay, these data are combined to the share the some share the network. Okay, next, biocomputing. Uses of biological molecules for computations. DNA used to store and processes data, highly energy efficient, still in research stage. These are two types of potential applications are there. First one, medical diagnostics and genetic analysis. These are the biocomputing in cloud paradigms. Next, mobile computing, MCC. Okay, these are the only using delivery in mobile apps. For the mobile computing is a method for using cloud technology to deliver mobile apps. Complex mobile apps today perform tasks such as authentications, location aware functions, and providing targeted contents and communication for the end users. These are the so many members are in using mobiles in nowadays. These are connected to the mobile devices and web services like cloud storages. Next, quantum computing. Quantum computing based on the quantum mechanisms uses a quite bit instead of a bit. Perform multiple calculations at a once. One extremely faster for a specific problem application. These are the cryptography using the quantum computing and drug discovery. Examples, IBM Quantum and Google Quantum AI, artificial intelligence. These are used for the quantum computing. Next, optical computing. Optical computing uses a light instead of electricity, faster data transformation, low heat generation used in fiber optical communication, high speed data performing, still under the development of the optical communication. Coming to nanocomputing. Nanocomputing is a nanometer scale, use nano-sized component, extremely small, like small and faster. These are the applications of the nanocomputing. Medical nanorobots, advanced electricity, emerging and technology. These are the computing paradigm of the nanocomputing. Thank you.